All right, our next presenter is Kyle Poisson. He's a geologist at HGL out of Billings. Kyle has expertise in geotechnical engineering, mining geology, and environmental geology. His comprehensive background encompasses geotechnical engineering design for both commercial and residential projects, conducting geotechnical soil investigations, executing environmental field investigations, overseeing monitoring point installations, and specializing in hard rock mining geology. He serves as the HGL field team leader and HGL deputy project manager for the Blacktail Creek project. So he's going to share his presentation on Blacktail Creek riparian actions of the Silver Bow Creek Butte area.
All right, thanks, Steve. So as Steve was saying, I'm Kyle with HGL. I'm a geologist out of the Billings office. First off, just want to thank the organizers. Thank you to Montana Tech, Susie. This is a wonderful conference, and I appreciate the opportunity to present and share this talk with y'all. Initially, Drew Herrera was going to present with me. He is currently busy. He's in good health. Do not worry. So I'll take the reins on this one. Either way, this is Blacktail Creek Riparian Action Project. Many of you are probably familiar, at least some of you are familiar with this site. If you were on the field trip on Monday, you stopped here and had lunch, I believe. So some of these site features, you might recognize them. In this picture right here, I just want to point out, this is looking at the project site. Not only is it scenic, but you do have this tailings berm right here. I'll be referring to that throughout the project or throughout the presentation. And then this wetlands area just beyond that. And then I-90, you can kind of see with the fence here, and then Highlands Mountains off to the south. This project is a DEQ project, and this is a tailings removal cleanup project, part of the Silver Bow Creek Butte area Superfund site. Okay, so for this, I'll be giving basically some introductions to the site. You kind of just had some of that. After that, we'll go into site location, features, site goals and objectives, status update, next steps and schedule, and then if we have time, questions and comments. In this picture here, some might recognize this. This is BIPSU outlined in yellow right here. So this is the BIPSU Priority Soils Operable Unit, part of that Silver Bow Creek Butte area Superfund site. And then kind of smaller in here, you got Blacktail Creek, that project area that I'll be talking about. Okay, this is more zoomed in. Definitely some features to point out here. Project area is outlined in red. Surprisingly not, I guess. Blacktail Creek goes through the site right here downstream and then meets up at the confluence with Silver Bow Creek. And primarily this site focuses on that confluence area and then just the Blacktail Creek and Blacktail Creek wetlands area. In here, there is a small section east of Lexington Ave. We did look at that section and did some sampling. I'll get to that more later. Other than that, you have I-90 here, Montana Street, George Street cuts through here, Visitor Center. I think you guys had lunch somewhere in here, and then Butte KOA right here as well. And then you have the BIPSU subdrain that has some lines that go through the north section of the site, as well as some sanitary sewer, electric, fiber, and the BMFOU, Butte Mine Flooding Operable Unit discharge structure, which we'll get to more to later. Okay, so I'm going to show a short video here, and basically this is an image overlay of 1962 historical aerial photography from when the interstate was built. Let's see if I can get this to work. Oh, there we go. Okay. So yeah, it's coming in and out here. you'll see this historical imagery and sort of focus on the Blacktail Creek section here. You're looking downstream towards the northwest, kind of at an aerial angle here. But what you'll notice is there's a berm, so that was, in that first picture in the title slide. But then some suspecting looking sediment kind of off to, I guess that'd be the southwest, right here in this area. Let me turn that laser pointer back on. So yeah, basically for this investigation, we used historical imagery, previous studies, some work done by Montana Bureau of Mines and Geology to design our drilling program. But this image was probably like one of the better historical images of the site. This site has changed a lot throughout the years. You have butte reduction works downstream. You have the I-90 going through here. And then, the wetlands here looks completely different today. There was some reclamation that happened kind of in the western portion of the site, which, I'll talk about that a little bit more as we continue. Main thing is just this berm right here. That berm was built out of tailings and used as a flood control method, basically. Throughout time, you had tailings aggrading into the streams, causing flooding. One of the solutions was to build a berm with readily available materials, tailings, I'll be talking about that more as we continue. Okay, so why? There's a lot of reasons why, but it really comes down to the BIPSU consent decree. This Butte Priority Soils Operable Unit Consent Decree is basically the framework for cleanup actions within the BIPSU. And basically, so you have the primary section, I guess, that addresses Blacktail Creek in some of the remedial action is Section 5, Attachment C of the CD, states remove tailings, wastes, contaminated soils and sediments from Blacktail Creek and Silverbow Creek below the confluence with Blacktail Creek, including Blacktail Creek wetlands, and control discharge contaminated groundwater to surface water in the area. DEQ is not responsible for the control of discharge of contaminated groundwater to surface water in the area. That's an SD responsibility, so we didn't look at that. But main thing here is remove tailings, waste, and contaminated soils and sediments. Furthermore, it says the total expected disposal quantities of tailings, waste, and contaminated soils shall be further investigated to select an appropriate repository. Contingency excavation and disposal plans shall be developed during the project design phase, subject to EPA approval and consultation with DEQ. To continue on, more detailed evaluation of the quantity, dewaterability, and geotechnical properties of the material to be removed shall be necessary prior to detailed design and implementation. So we looked at basically, this total expected disposal quantity, dewaterability, and geotech properties. Okay, so continuing on, Section 3.4 of Appendix H to the CD outlines more of the Blacktail Creek riparian actions, and basically the purpose of the PDI is to address data gaps by conducting additional field investigations, evaluate existing data, identify data gaps, and then collect additional design level data. And so the identified data gaps were basically depth and extent of removal, potential for non-mining waste to be present, magnitude of groundwater dewatering, disposal requirements, borrow source, and then some other issues. Okay, so this leads us to the PDI, pre-design investigation. We broke it up into two phases. Phase 1 had the majority of the investigation, so that included evaluating data gaps, assessing usability of the existing groundwater models for dewatering modeling, soil borings, which consisted of XRF in the field, XRF in the field lab, and then further lab analysis of that soil. And then preliminary removal surface and volume, and that was done using Carlson software and looking at basically different layers in modeling and finding the extrapolated surface between contamination, which will make a lot more sense when I continue with this. So other than that, preliminary groundwater removal demands, which came from groundwater modeling, and that was basically a calibration of an existing groundwater model. And then geotech assessment ended up being a geotech review, and phase 2 would basically be a further geotech investigation, more in depth if that geotech review basically showed the need for it. And at this time, that geotech review seems to be sufficient. So phase 1, phase 2, eventually it would end up in the PDI-ER, which is the pre-design investigation evaluation report. We just finished that up, and it's in review process right now, so it's not officially approved. So some of these results I'll be sharing, or I won't get into specific detail, but yeah, the majority of the results are in this presentation. Okay, so phase 1 PDI, getting into quantifying the tailings, waste, contaminated soils and sediments, looking at groundwater, specifically for dewatering demands during removal, which came down to volume and quality of water. There's a lot of chemistry data from groundwater in the area. There's a lot of wells, so we looked at groundwater chemistry and then tied that into the dewatering groundwater modeling to be able to come up with rates and then expected chemistries for dewatering during construction. After that, we went into the geotech report, and so that specifically addressed excavation and in regard to stability and settlement. Major components of this investigation came down to waste identification, which is your tailings, waste, contaminated soils, and sediments. That's a mouthful, so waste, much easier to say. Waste identification criteria, it comes down to table 1 from the BIPSU consent decree, and that's what you're looking at right here in the lower right-hand corner of your screen. If any 3 of these contaminants of concern were exceeded, so arsenic, cadmium, copper, lead, mercury, zinc, it was considered waste and categorized as waste. Or if any one of them exceeded 5,000 milligrams per kilogram, it was considered waste. So in addition, we also looked at hydrocarbons with PID and lab analysis, and then municipal waste, looking at debris, just visual identification, and then submitting samples for suspect asbestos-containing material analysis. Groundwater modeling, as I've talked about, and then the geotech review. Okay, so PDI schedule. Last year in August, the PDI work plan was approved, August 2023. Field work was completed in August and September of 23. XRF, most of the lab work and analysis, that was all completed in November. Developed the preliminary excavation surface in December of 23. And then phase 1 PDI-ER draft is complete as of a couple weeks ago. And so basically looking forward, other investigations, the only one we really are looking at is a borrow source investigation pending results of PDI-ER review. Okay, so I'll get into the investigation. This is the layout right here of basically the drill program. You have all of these boring location proposed drill hole locations in the center of the site and then up in the northwest section of the site. And then down here in the southeast section of the site, you have 4 trench sample locations and then 4 sediment stream sample locations. You'll notice these borings are separated by color, and so there's there's 43, which is a lot of borings, 43 green proposed drill hole locations, and then 13 of the yellow ones. And those green ones were basically priority 1 drill holes, and then the yellow ones being priority 2. The reasoning for that was basically this site, you have a lot of sediment, you have tailings, it's a wetland area, you have streams. So basically it comes down to highly saturated sediments, and getting recovery from borings in those conditions is difficult. And so that was the other reason for going with sonic drilling versus other methods. Having that priority 2, though, if for some reason we were having difficult recoveries, weren't able to connect the dots, we'd go ahead and start drilling these priority 2 borings. We only really had, questionable recovery on some of the borings, not much. We had an 89% recovery overall, which is really good. So only one of the priority 2 borings was drilled, which is this right here, BTC 43. Okay, so here's some pictures of the investigation itself. Here you have, this is basically what the setup looked like. You have a sonic drill rig, couple trucks. This is to move equipment for the rig, and then we set up a tarp for processing of the core, and basically we logged the core, we took pictures of the core, we XRF'd the core, we PID'd the core, and we also took mercury samples in the field during the investigation. So yeah, we got very familiar with the core out in the field. Yeah, moving to the right here. So this is a Vanta C-Series XRF. That's what we ended up using for this project. And yeah, I conveniently placed plastic bag to keep the analyzer window clean. And that seemed to be a good method. We did do some QC type things, so duplicate scans using NIST standards to make sure the XRF was calibrated, things of that sort to ensure that our method was working well. One thing to note with these sites, some of you may know with XRF, it starts to bias low once you get over 20% moisture. So our field XRF was based off of stream side numbers. Basically, it is about 20-30%. It was more of a correlation from stream side, but numbers that were lowered based if we encountered highly saturated soils, which the majority of the site was, we would use those thresholds, those criteria. Actually ended up working quite well. Out of the 43 borings that we drilled, only I think 15 were adjusted based on post-field XRF and post-lab analysis. Down here you'll see we collected everything in 5-gallon plastic buckets that worked really well. So each interval was collected into gallon-sized bags and then labeled and then placed in buckets. This was a really good method. I think we initially were going to go with some soil core boxes. For this type of material, those boxes, it just ends up being a nightmare. So this was a great way to basically contain the samples, store the samples, and then later on go back and get samples for metals testing. Okay, so this picture here, you'll see a cross section, A to A prime. Just kind of hold this image in your mind as we go forward. I'm going to show you, this isn't a cross section. This is the line for the cross section. I'll show you the cross section here in a second. Basically, this cross section is going to go from I-90 through the site and then up to the visitor center. Okay. Couple features to point out here, and this is probably the most visually interesting slide as far as results go for this update, so I'll probably spend some time here. I-90, I-15 off to the left here, this is all topography. This is a 10 times vertical exaggeration cross-section just to blow it up to be able to see features a little more easily. Going across, there's 3 borings here, and then you have 2 proposed excavation surfaces that were created based on on lab data and then XRF as well. And then you have the existing water table, and then basically a drawdown water table, if you will, from basically our groundwater dewatering modeling. And then if you can continue up here, you have the trail, the parking area, if you will, and then the visitor center. So general trends, geologically speaking, is we saw there was a fill of sorts, which was either a clay fill or sand fill, tailings, but just didn't qualify as waste. And then down below, waste, which is your tailings, and then some contamination into native soils, also classified as waste. And then below that, you have your native soils, so sand and silts. There was a clay layer. There's not a lot of continuity with that clay layer at this site. There's certainly silts and clays, and it's hard to differentiate the two unless you do some type of geotech testing in a lab. Below that, you have alluvium, gravel, and sand, and that was basically our indicator lithology. Once we hit the alluvium, we knew we were definitely out of contamination, and we did not need to drill further. So the idea was to identify the contamination in the field as best we can, confirm with lab data later on, and then, lost my train of thought. But yeah, then from there, go into, all right, we're gonna skip that sentence, I apologize. Okay, so I'm gonna talk about these excavation surfaces right here. These right here, the green one was the initial surface that we created. And based off our geotech assessment, we went with a type C soil, 1.5 to 1 slope as the steepest slope that we could achieve safely. So these slopes is what you're showing here. If you start that excavation at the boundary, you end up skipping a decent bit of material. So a possible solution, design has not been has not gone through with yet. So possible solution would be to do what this blue excavation surface is showing you, and basically excavating down to that boundary, setting the toe of the excavation to the boundary, allowing you to get complete removal within the project area. We did see tailings outside of the project area in areas, in this one especially here, there's a groundwater hydraulic control that's planned for this area to mitigate that contamination. Okay, here is a three-dimensional model of the excavations. You have I-90, I-15, George Street, and then Montana Street, and just two main excavation areas. The northwest project or area, the project area, that section right there had contamination throughout the whole section, so that'll be a complete excavation. And then down here, you'll notice it's clipped. This is basically where that contamination ends, and the tailings no longer present. Okay, all right. So I'm going to get into the groundwater dewatering modeling a little bit here. This is a groundwater contour map. You have 8 extraction wells, simulated extraction wells here. That's one method for the groundwater dewatering, but for all intensive purposes, we were just looking for rates of dewatering and volume to get an idea of what we can expect to have to dewater. Most of this, or I should say all of the construction dewatering at this point, will need to be treated and sent to butte treatment lagoons. So it's super crucial to know what's expected as far as rates and volumes go, so that BTL, butte treatment lagoons, is not exceeded as far as their capacity goes. In this picture here, I'll just point out a couple features. There was basically 2 phases that were run with the groundwater dewatering modeling, and one was with BTC, Blacktail Creek, in place, and then one was without Blacktail Creek, assuming you could pipe the creek. And I'll show you the results of those rates. So here in yellow, basically you have north of George Street, and then in blue you have south of George Street. So those are the 2 excavation areas that showed in the 3D model. North of George Street, Varies with a starting rate somewhere between 600 to 1,000 GPM, working your way down to somewhere in the 400, or I should say 300 GPM range. South of George Street, similar-ish trends, starting somewhere around 800 GPM, and then working your way down to a steady state of maybe 500 GPM. So definitely, a fair amount of dewatering it will be required for this site, and then going from there, figuring out scheduling, phasing, to be able to send that construction dewatering water to butte treatment lagoons is going to be crucial during the design process. Okay, key findings. I should say excavation volumes are similar to previous assumptions in the BIPSU consent decree, and around 200,000 cubic yards is basically what we found, give or take, pending results. And then excellent recovery from sonic borings, 89%. We had a good modified ex situ XRF and lab correlation, generally good results from the existing site groundwater model. Limited municipal waste on site. No asbestos was found. No hydrocarbons of concern were found. And then overburden is generally not reusable. We did find some pockets where we had some criteria A or B backfill soil that were good contenders, but it was basically intermittently placed and not reliable. So generally speaking, clean fill is not at this site. Okay, next steps. So we'll finalize the PDIER this summer, borrower source investigation probably this summer, RDWP finalized this summer 2024, remedial design 24-25, remedial action 26-27, monitoring O&M 26 to 29, and then close out around 2030. And I'll show you a visual basically of that same thing here. Working through starting in 2022, contractor startup. Here we are right now in 24, PDIER, working for remedial design starting probably sometime in June, and then all the way to project closeout in 2030. Just want to thank a couple of people. I won't read this entire list, but thank you to DEQ, EPA, Butte Silverbow, HGL project team, O'Keefe Drilling, Lorenzen Soil Mechanics, NRD, Brown and Associates, and then Montana Department of Transportation. And with that, I'll take questions.
All right, thanks, Kyle. Questions?
Yeah, are you going to need to go through a complete waste disposal evaluation, similars that we're seeing now with the Butte Priority Soils upcoming work, or do you anticipate a potential to be able to piggyback on that plan?
Yeah, no, good question. We are looking at that currently and looking to do some additional testing on that archived soil material, be able to see if, what are the options for this waste disposal. From there, if we can piggyback, I think we certainly would, just to keep things efficient. It'll just depend, how things play out with the different parties involved.
Any more questions?
What kind of average core lengths were you getting out of those holes?
17 feet.
Excuse me?
So they varied from 15 to 25 feet, but the average was 17 for all the boreholes. Yeah.
Okay. And you were putting that into one bucket or more than one bucket?
More than one, yeah, probably, 3 buckets. Yeah.
You had several locations east of Caw or Lexington Avenue.
Yes, yep.
Did those come back clean?
Yep, that was all completely clean.
Cool.
Anyone else? All right. Thank you, Kyle.
Thank you.